right, so this is section 2.1, quadratic functions and models. So today you're learning a couple of models, two different models that we'll be familiar with. And again, I'm going to collect your notes tomorrow, so you want to just make sure your name is on your notebook. Inside cover is usually good. You'll turn them all in. All right. And here are your two different models. Lots of information here. You definitely want to write it down. Useful information here. Two different forms. We have general form and standard form, which are in different fonts that I didn't realize, and that's really annoying to me. So, okay. So I'm going to talk through a couple of these things. So we have two forms here. We have what's known as general form, and we have standard form. So general form, every book uses a different name, okay? I wish they would just call it ABC form, because you see the A and the B and the C, it makes sense. Okay. Incredibly logical. But they call it, I guess, general form, and all I can think is like general, and I've got all my ducks in a row, like, you know, lined up. Does that kind of make sense to you? Okay. So there we go. General form or ABC form. So all of these are quadratic. What shape is a quadratic equation? Yeah, of course, it's a parabola. So both of these are parabolic in shape, and every parabola has a vertex. The vertex is the minimum or maximum of the parabola. So they all have a vertex, which in this case happens to be the minimum or the lowest point on the parabola. You can find the vertex as an ordered pair. The x-coordinate is just negative b over 2a. So when we're in ABC form or general form, negative b over 2a will give you the x-coordinate. And then if you want the corresponding output, well, that's what this means. This says go back to your function and plug that value back in. You have an x, plug it in, it'll give you the y. So that's f of negative b over 2a. So just plug it back into the function, and you'll get your xy ordered pair. Every parabola has an axis of symmetry. I really don't care very much about the axis of symmetry, but basically the axis of symmetry is just always your x-coordinate of the vertex. And it is the line of symmetry where the parabola can reflect around itself, okay? So that's where you put the mirror, and one side, the left side, is identical to the right-hand side, the mirror reflection, okay, along that axis of symmetry, which has nothing to do with whether it's an even function or not, okay? Even is specific reflection around the y-axis, symmetry with respect to the y-axis, so be careful. The y-intercepts you can get always by plugging in a 0 for the x. If you plug in a 0 for the x, you would have 0 plus 0 plus c. So when you're in general form, it turns out that whatever that constant is, that value on the end, happens to be your y-intercept. So that's kind of nice. Okay. If you want to find the x-intercept, you're going to set your function equal to 0, and you're either going to factor or use the quadratic formula to find your x-intercepts. Okay, so got to know the quadratic formula. If you don't have it memorized, you need to memorize it. It is a requirement. All right. Standard form, or my preference is to call it HK form. Standard form is actually the most useful form we have. And we can tell a lot from standard form. It turns out it's pretty easy to use. The vertex, when we're in standard form, the vertex is HK. We've seen this form before when we were working on transformations, and that's what your project deals with on Thursday and Friday. It's working more with transformations and all kinds of equations that are in standard form. So when we were doing transformations, this was our parent function was x squared, and it was shifted h units left or right and k units up or down. And then it had a vertical stretch or shrink of a. Okay, so all that sort of getting put together in this nice form. Again, the vertex is HK. So if you're in standard form, finding the vertex is really simple. The axis of symmetry is just whatever that x coordinate is, in this case the h. And finding your intercepts is also really easy. The y-intercept, you're going to plug in a 0 for x and just simplify to figure out the y value. And to find the x-intercept, you're going to set it equal to 0 and then solve for x. So standard form is actually really, really nice. We like it a lot. You're going to get to use both of these forms a lot today. So here we go. Example 1. Sketch the function. Your job is to sketch the function. And identify the vertex, axis of symmetry, and the intercepts. All, God bless you, all the important characteristics of any graph. The vertices, if there are any, vertex, the intercepts. I don't really care about the axis of symmetry, but it's kind of a 2 for 1. Find the vertex, you've also found the axis of symmetry. We do want to sketch the function. When we sketch the function, it is a sketch. Really, I want you to label the stuff. That's it. The other thing is you can do all of this and you can check it on your calculator, which I think is key. So definitely want to be checking your work as you go. Okay, so we have the function y equals negative 2x squared plus 4x plus 6. What form is this equation in? General form, or ABC form. And so the first thing we want to do is identify the vertex. How do we find the vertex when we're in general form? Yeah, x equals negative b over 2a, which is kind of very similar looking to the quadratic formula, right? There's a little bit of that in there. So negative b over 2a, the opposite of b would be negative 4 over 2 times negative 2, 2 times a. And that's, of course, negative 4 over negative 4, which is 1. So that's the x-coordinate of your vertex. How do we figure out the y-coordinate? Yeah, plug the 1 back into your function. So we want to find f of 1. So I'm using f for y, doesn't matter. F of 1, so that says plug in a 1. So negative 2 times 1 squared plus 4 times 1 plus 6. I think I can do that. 1 squared is 1. So that's negative 2. Plus 4 is 2. Plus 6 is 8. So my vertex is at 1, 8. I found the vertex. That also gives me the axis of symmetry. What's the equation for the axis of symmetry? X equals 1. Yeah, negative b over 2a, which just happens to be 1. The same thing. We already found it. So that's kind of nice. When we are in general form, what is the y-intercept going to be? 6, yeah. Y-intercepts are found when we plug in a 0 for the x-coordinate. So when I plug in a 0, well, that's going to be 0 plus 0 plus 6, which is just 6. Is just that constant on the end. And then I also want to find the x-intercept. How do we figure out the x-intercept? Set the equation equal to 0. Yeah, so we're going to set y equal to 0, which means we have 0 equals negative 2x squared plus 4x plus 6. And we're either going to try to factor or use the quadratic formula. What can we do with this?
Factor.
You can factor, you can take out a negative 2. Can I go ahead and divide everything by negative 2? Yeah, boy, I'd like to do that. I'm equal to 0, so it's totally acceptable to divide through and make all our numbers smaller. So 0 equals, that's going to be 1x squared, negative 2x, and 6 divided by negative 2 is negative 3. And now we can double bubble. Factor. X times x is x squared. What times what is negative 3? -3, and +1, which means we get x equals 3 and x equals -1. Anytime you're solving for x, you're finding x-intercepts. Well, that means when x is 3, we got a 3 when y was equal to 0. And we also got a -1 when y was equal to 0. So we have 2 x-intercepts. So I am going to make a super, super quick sketch here. Is this an up parabola or a down parabola? How do you know it's a downward facing parabola? Yeah, the negative in front makes it a downward facing parabola. It's not too important because if I was to sort of sketch these x-intercepts here, -1, 0, 3, 0, you'll notice I'm not doing tick marks. I'm just plotting and labeling. My y-intercept is 0, 6, and my vertex is 1, 8, which is the highest point of my parabola. And there you go. Plot your points and draw a U through them. And that's an exceptionally good graph. Can you check this on your calculator? Absolutely. You have a function, so you can check it on your calculator. You can graph it and then use trace to check all of these ordered pairs. Okay, and I'll do one in a little bit where I'll show you one of the higher ones. Okay, so use trace to check each of those ordered pairs, and it's awesome. Okay. All right. Letter B, what form is this one in? General form. Again, ABC form. So we want to find the vertex. How do I find the vertex? That's the x coordinate, -b over 2a. That would be -6 over 2 times 1, which is just -3. So that's the x coordinate. How do you find the y coordinate? Plug it in, sure. Take your function and plug in that -3 to it. So that's going to be -3 quantity squared plus 6 times -3 minus 5. And those numbers are too big. So 9 minus 18 minus 5. -14. It was a long vacation. I did quite a lot of binge watching. Yeah. Outlander. Yeah. Okay. The axis of symmetry is what? X equals -3. Make sure you put the x equals on there because it is an equation of a line. -3, I don't know what that is. That's just a number. X equals -3 is an equation of a line. Y-intercept. How do you find a y-intercept?
It's the C.
It's the C, and in this case, that would be -5. So again, don't just put -5 because that's kind of meaningless. But 0, -5 says if you plug in a 0, you would get a -5, and that's your y-intercept. X-intercept. How do you find an x-intercept? Set y equal to 0. So we have 0 equals x squared plus 6x minus 5. And then how do you solve for x? Double bubble. Does this double bubble? Let's see. X times x is x squared. What times what is -5? That's +5. -5 and +1 gives you -4. Does it factor? No, it does not factor, which means we have to do what? The quadratic formula. Yes. Okay. X equals the opposite of b, so that's going to be -6 plus or minus the square root of b squared. Again, this is something I'm going to do in my head. B squared, 6 squared is 36, minus 4 times a times c. I'm going to do 4ac in my head. 4 times -5 times 1, or 4 times 1 times -5 is -20. all over 2 times 1. Folks, be super duper careful when you simplify using the quadratic formula. You need to do it right. There's a million different ways to do it, but just do it right. So we have -6 plus or minus radical 56 over 2. 56 simplifies. What times what is 56? 28 times 2, which means 4 times 14. Close. Yeah. All right. So how does radical 56 simplify? 2 radical 14. Okay. And what is this 2 dividing? Everything. So it's going to divide each thing. Ladies and gentlemen, I encourage you to split that up. Divide each term by 2 so that you simplify correctly. This is the step, folks, that I am going to get you on a test. 2 radical 14 divided by 2 cleans up to just radical 14. So those are your x-intercepts. I'm going to split it up just so I can check on my calculator. One x value is -3 plus radical 14 and a 0 for y. And the other one is -3 minus radical 14 and a 0 for y. I'm not going to graph this one mostly due to space, but I am going to do it on my calculator. So you would have to sketch it. Here it is, x squared plus 6x plus 5, or sorry, minus 5. So I've typed it in my calculator. I'm going to do a zoom standard. So this is the standard window. And you'll notice I can't see the bottom. I can't see the vertex of my parabola. So I need to change my window. I need my y values to get lower. So I'm going to change my window, and I want my y minimum values to get a little bit lower. So I'm going to change that to -20. You can do that on a Casio too. It's under viewing window, V window. All right, so now I can see everything, and I'm going to type in all the information here and see what happens. So I'm going to use trace, and I'm going to type in -3. And sure enough, that gives me my vertex at the bottom, -3, 14. I can check my y-intercept. I can plug in a 0 for x, and it gives me my output of -5, and it is crossing at the y-axis. I can even check these crazy answers. -3 plus radical 14. I can type in the exact answer, and you can see it. There it is right there on the x-axis, and it has an output of 0. So that one is checked as well. And I can try -3 minus radical 14. And there's the other x-intercept, and the y value is 0. So you can check those crazy ones also, all right? So pay attention to that. Make sure you do that. Really, this class is about learning how to use your calculator. If you haven't figured that out yet, you've had a whole quarter.
All right, let's do our work.
Now let's do a couple more. So here it is. Letter C is a little different form. F of x equals 4 plus 2 times the quantity x plus 3 squared. What form is this? Standard form. Huh, it is standard form. But it doesn't exactly look like standard form. What's going on with this form? Yeah, it's sort of reversed. This was really the k that normally would be on the end. So if you wanted to rewrite it so it was identical to standard form, this is a positive 4, and you can relocate it to the end of the line, if you will. Just make sure you don't do 4 plus 2 is 6. Okay? Can you do 4 plus 2? No, because you got a whole product over here that you got to worry about. So this is 2 times the quantity, x plus 3 squared, and then the plus 4 on the end. So yes, it is in standard form. You can rearrange at will. What is the vertex? -3, 4. Very good. -3, 4. H and K, remember, why is it -3 instead of +3? Yeah, it's The formula is x minus h. So x minus what number? Minus a negative 3 is why it turns to plus 3. So that's how you can think about it. All right, you know that. You also know, whoops, the axis of symmetry. What's the axis of symmetry? X equals negative 3. Y-intercept. How do you find a y-intercept? Set x to 0. X equals 0. So we can do that. So I'm going to plug in a 0 for x. So 2, and then 0 for x. And then all I have to do is do a little bit of simplifying. 3 squared. 3 squared is 9, times 2 is 18, plus the 4, so we get 22. So we have an ordered pair of 0, 22, and that's the y-intercept. How do you find the x-intercept? Yeah, you set the y equal to 0, or our function itself equal to 0. So that's going to be 2 quantity x plus 3 squared plus 4. So we set the y value equal to 0. That allows us to solve for x. So for all the money in the world that I don't have, how do you solve for x? Subtract 4. Okay, good. So we're going to subtract 4. And then divide by 2. All right, so that's negative 2 equals x plus 3 quantity squared. And then square root. What do you need to remember when you take a square root? Plus or minus. Don't forget the plus or minus. And what happens here when we take the square root of negative 2? It's imaginary. All right, which means you can stop for now. I don't think they have you solve for the imaginary roots. But what does that mean if when we go to solve for x, that it turns out to be imaginary? What does that mean? It's not real. What does it mean if it's not real? There aren't any to see. There are no real x-intercepts. And that means that we don't see them. It doesn't cross the x-axis. In imaginary land it does, but this is the real world. Okay, so again, I want to sketch this. I know my vertex is at negative 3, 4. I know I have a y-intercept of 0, 22. You'll notice I am not going to do 22 tick marks. Not on your life. Plot it and label it. And that's all you need to do. And this is where the axis of symmetry is useful for us. Because if I know one side of the parabola, then I can just flip it over and graph the other side. I don't need you to be that exact. So this is good enough for government work. Okay? It's my favorite thing. It's how I justify not working my hardest. Okay? I lovingly call, whenever we have no real x-intercepts, I lovingly call the parabola a floater. Oh,
Basketball.
Oh, is that what you were thinking? Funny, I wasn't thinking about basketball. Okay. All right. Example 2, last thing. Write the equation of the parabola that has the indicated vertex and passes through the given point. We have done this already. You know how to do this, so it's just easier today. How about that? They also tell you in standard form. Standard form is HK form, that form with H's and K's. And the reason we want to use standard form is because of what they gave us. They gave us the vertex. And when they give us a vertex, they're giving us an H and a K value. And so that's really, really useful. When in some of your problems you have a graph, so negative 1, 2 might be labeled, and then the point like 2, 3 is on there. And so you might have a picture of a parabola. We'll pretend that it passed through the point. There we go. Okay. And so if you look at that picture, you can also tell that you are given the vertex, which is H and K information. So since I know I want to use standard form, I'm going to go ahead and write down standard form, which is y equals A times what? Oh, yeah. Okay, I'm going for the basic form. X minus H quantity squared plus K. And then I can go ahead and plug in my H and K. So that's going to be X minus a negative 1 or plus 1, and then plus the 2 for the K value. So again, we've done this before. I need to know what A is. How do we figure out A?
Plug in the
Yeah, plug in the point. Ladies and gentlemen, anytime you're given a point, that you're giving you a solution, an answer for X's and Y's. And so we're going to plug in that information. We're going to plug in the 3 for the Y and the 2 for the X. And that's going to allow us to solve for what we need A to be. So I'm going to clean this up a little bit. I have 3 equals A times 3 squared plus 2. Okay, now what do you want to do? You do 3 squared. You want to do that first? Okay. So 3 squared is 9. So I'm going to write 9A plus 2. Now what? Subtract 2. All right. So it's going to be 1 equals 9A. And then divide by 9. So 1/9. Are we done? What do you got to do with the 1/9? Plug it back into your equation. So you get 1/9 times the quantity X plus 1 squared plus 2. Can you check this equation?
Yeah.
Yes, absolutely. It's an equation. Use your calculator to graph it, and then use trace to check the points. Okay? Absolutely, definitely check a couple when you're doing your homework. Every single thing today you can check using your calculator, so do it. Learn to use your calculator because it'll save you on a test. Do you have any questions for me? All right, ladies and gentlemen, you may begin. Homework 46.
Oh, you